Yes, quite, Nyasha. You can see the presentation.
All right, so good afternoon, ladies and gentlemen. My name is Nyasha. I'm going to be presenting with my colleagues, Polycarp and Fortune Muresherwa. So we are going to be doing the introductory part of cloud computing. So I'm going to just start by defining that cloud computing is it's an on-demand availability of computing resources, which include storage, servers, databases, and software over the internet. Allow access and pay only for one. So a CSP offers cloud services from remote data centers on a pay-as-you-go or subscription basis. The characteristics of cloud computing includes the fact that it's got an on-demand self-service where users can provision and manage resources independently without human intervention. It also allows for broad network access where services are accessible over standard networks and compatible with diverse devices. And also it has rapid elasticity where the IT resources can quickly scale up or down basing on demand. It also has resource pooling where IT resources such as network, servers, storage are shared among multiple clients from the same physical infrastructure. It also has multi-tenancy, where cloud providers support multiple tenants or users or organization share resources. It also has virtualization, where providers use virtualization to abstract hardware resources, presenting them as logical resources to users. It has measured services, like we've already said.
Excuse me, Madam Nyasha.
Yes.
While you are presenting, I think it's necessary for me to interject. We are expecting some real-world examples. For example, on multi-tenancy, how does is a characteristic of the cloud multi-tenancy supported, and what are the real-world examples that we have for that one, so that it doesn't become just a presentation where you are reading and we are listening. We need real-world examples to support whatever you are telling us. You need to share with us all that. So what you do, you can go ahead with your presentation right now, while your other group members will be looking for this, so that at the end of this we will discuss and you will be giving us those real-world examples. So you can go ahead now, or we have them somewhere. Sorry, probably we have them somewhere. You can go ahead.
Sorry, sir, before we move on, can you please record the lecture?
Oh, sorry. I'm sorry for that. Thank you very much, Madam Miss.
Okay, sir.
You can go ahead.
Okay, so I was thinking that maybe I present first and then we can offer the example.
Well, go ahead.
Oh, okay. Then in terms of virtualization, we are saying providers use abstract hardware resources, presenting them as logical resources to users. And then we also said it offers measured services so that it's really efficient, and also users can pay as they use the service. It also is for redundancy, fault tolerance, ensuring high availability and reliability. So it has flexible models. It's also secure and has invested in privacy. The system is also automated, so cloud services are highly automated, enabling users to deploy and manage resources with minimal manual intervention. It is also sustainable, where cloud providers emphasize sustainable practices, including energy efficient data centers and renewable energy sources to minimize environmental impact. So I've just put together this picture of some of the characteristics of the cloud computing, like on-demand self-service, broad network, resource pooling, rapid elasticity, and that it offers measured service. So the basic idea of cloud computing is sort of like renting a bunch of computers, also known as infrastructure as a service. An example is AWS, which can offer and power of a machine running a software that has smaller computers, which are known as virtual machines. So when you are running your website, you can be renting these virtual machines like AWS, high traffic our server cannot handle. Then you can also include the use of a load balancer that helps distribute risk even across these virtual machines. So when the traffic is low, or when you now have less requests to handle, you can then just switch off the other virtual machines. So the idea began in the 1960s with Dr. Joseph Carl Licklider, who introduced the concept of global networking. And his vision was an intergalactic computer network. And then in the early 2000s, so it marked the start of cloud infrastructure for business. And then in around 2002, Amazon Web Services then launched based storage and computing services. In 2006, introduced Elastic Compute Cloud EC2, which allowed users to rent virtual computers. And then in 2006, Google then launched Google Apps, now Google Workspace, a suite of SaaS to productivity applications. And then in 2009, Microsoft released its first SaaS application, Microsoft 2011. Then Gartner then predicts that worldwide spending on public cloud will reach something like 679 billion and projected to exceed over 1 trillion by 2027. So these are some of the emerging technologies supported by the cloud. Containers, serverless, microservices, Internet of Things, artificial intelligence, edge computing, open source, the scopes. Okay, so the next part is going to be presented on by my colleague Fortune, and then Polycarp will focus on the last part, and then can discuss into in depth of our presentation. Thank you. Over to you, Fortune.
Okay, so I will present on the differences. So the first one is on cloud computing versus edge computing. Sorry, am I audible?
Yeah, audible indeed.
Okay, thank you. So the first one is on cloud computing and versus edge computing. So the first difference is on location of the data processing. Cloud computing data is processed and stored in centralized data centers or cloud servers, which can be located anywhere in the world. Whilst edge computing data is processed and stored closer to the source of the data at the edge of the network, such as on IoT devices, gateways, or local servers. Then the next difference is on latency. Cloud computing data has to travel from the source to the cloud data centers, which can introduce higher latency, especially for applications that require real-time or near real-time responses. and edge computing data processing occurs closer to the source, reducing the distance data has to travel, resulting in lower latency and faster response times. Nyasha, can you scroll down, please?
I have.
Okay. So the next difference is on bandwidth requirements. Cloud computing requires a reliable and high bandwidth network connection to transmit data to and from the cloud, as large amounts of data need to be sent to the cloud for processing. Whilst edge computing reduces the bandwidth requirements as only the necessary data. Nyasha, may you please mute your mic?
Okay.
Thank you. So edge computing reduces the bandwidth requirements as only the necessary data or results need to be sent to the cloud, reducing the amount of data transmitted. Then another difference is on resilience and fault tolerance. Cloud computing leverages the extensive infrastructure of cloud providers, which can provide high availability and fault tolerance. On edge computing, distributed nature of edge devices can provide some level of resilience, but the failure of individual edge devices can still impact the overall system. Nyasha, next slide. Okay, the next difference is on data privacy and security. On cloud computing, data is stored and processed in the cloud, which may raise concerns about data privacy and security, especially for sensitive or regulated data. Then on edge computing, data is processed and stored closer to the source, reducing the risk of data exposure and potentially improving data privacy and security. We move on to scalability, which is another difference again. So cloud computing offers virtually unlimited computing and storage resources, making it highly scalable to handle increasing data volumes and processing requirements. And edge computing scalability is more limited, as it relies on the resources of individual edge devices or local infrastructure. To computing versus fog computing. The first difference is on of process. Cloud computing, data and storage primarily occur in centralized data centers and servers. And fog computing and storage happen closer to the edge of the network. Next slide, Nyasha. Okay, then data movement and bandwidth. Cloud computing often requires large amounts of data to be transmitted from edge devices to the cloud, which can consume significant bandwidth. Fog computing aims to reduce the amount of data that needs to be sent to the cloud by processing and analyzing data at the edge, thereby reducing the load on the network and the overall bandwidth requirements. Next slide is on scalability resilience. Cloud computing offers virtually unlimited scalability as cloud providers can easily scale resources to meet the growing demands of users and applications. Wireless fog computing can provide a more distributed and resilient architecture as the processing power is spread across multiple devices at the edge, reducing the impact of a single point of failure. And another difference is on latency and response time. Cloud computing, due to the centralized nature of cloud computing, there can be higher latency and slower response times, especially for applications that require real-time or near real-time processing. Wireless fog computing is designed to reduce latency and improve response times by processing data closer to the source, minimizing the need to send data to the cloud. Applications. Applications and use cases. Cloud computing is well suited for applications that require centralized processing. Fog computing is beneficial for low latency real-time applications at the edge. Next slide, Nyasha. So I am moving on to edge computing versus fog computing. So the first difference is on proximity to data sources. Edge computing data processing occurs extremely close to the source of the data, often on the same device or a local gateway. Fog computing data processing happens closer to the edge than the cloud, but not necessarily on the same device as the data source. The next difference is on latency and real-time processing. Edge computing provides the lowest latency and best real-time processing capabilities. Then fog computing offers lower latency and better real-time processing compared to cloud computing, but may not be as low as pure edge computing. Serverless computing versus edge computing. The first difference is on compute location. Serverless computation is executed on managed, scalable, and event-driven cloud infrastructure. The physical servers are abstracted away from the developer. Computation is performed on local devices or gateways at the edge of the network, close to the source of the data. Then on latency and real-time processing, serverless functions may incur higher latency due to the need to invoke the cloud-hosted services, which can impact real-time applications. Edge devices can process data locally, enabling low latency and real-time responses, which is crucial for time-sensitive applications. I move on to data processing and autonomy. Serverless computing data is typically processed in the cloud, which can require data to be transmitted over the network, potentially impacting bandwidth and privacy. While edge computing data can be processed on the edge devices themselves, reducing the need for data transmission and enabling more autonomous decision-making at the edge. Then on scalability and resilience, serverless computing, serverless functions can scale automatically to meet demand, but the overall system is still dependent on the availability and reliability of the cloud infrastructure. And edge computing, edge devices can provide a more distributed and resilient architecture as the processing power is spread across multiple devices, reducing the impact of a single point of failure. Another difference is on development and deployment. Serverless computing, developers focus on writing functions and defining event triggers, while the cloud providers manage the infrastructure. Computing, developers need to consider the constraints and capabilities of the edge devices, as well as the distributed nature of the edge computing architecture. So the next part will be presented by Polycarp.
Thank you, Fortune. Thank you, Nyasha. Am I audible?
Yeah, you're audible, sir. Go ahead.
Thank you. I'm going to present on cloud infrastructure, starting from the history of data centers, then data centers and its components, then also the design considerations when designing a data center. Next slide, Nyasha. First, I'm going to define a data center, which in simple terms is a facility that is used to house computer systems and all the associated components, such as telecommunications and the storage systems. Next slide, Nyasha. Right. Then on the data center layout, a data center basically has three different spaces that are common that we want to talk about. The first one being the IT room, also known as the data hall. Then we have the support area, then also ancillary spaces. So the data room or the data hall, this one it is the IT room that is environmentally controlled. That is an environmentally controlled space, and it houses all equipment and cabling that is directly related to all compute and telecommunication systems, and also those equipment which actually generate a considerable amount of heat in a very small area. So all the IT equipment, like the servers, the telecommunication systems, they are housed in the IT room. Then the support area. This one, these are areas that that house systems like the power, the systems to do with the power supply, then also cooling systems. They are part of the support area. And basically speaking, these areas are, they have an interrupted power supply, then also the UPS rooms, and also the power backup systems and all cooling equipment area and control rooms. They fall into the support area of the data center. Then ancillary spaces, these may include things such as offices, lobbies, and even restrooms as part of the data center under ancillary spaces. And from the diagram, with a typical layout of a data center, where in the green part we have the data hall, which is the main part, actually the biggest, and also then the cooling equipment to cool the data center. With control rooms, then electrical gear or UPS, where we have our power system and power supply area. We have the entrance where we also have security there. Then, of course, the power backup area. That gives us an overview of the general layout of a data center. Next slide, Nyasha. Right. Then moving on to the components in a data center or data center components. Data center components, a data center comprises of subsystems, and we have three main subsystems we want to talk about. And all the components we are also going to discuss later, they fall into those three categories. We have components to do with IT equipment, then components to do with power system, then also components to do with the cooling system. Now, discussing the IT equipment is actually the primary area of data center, and data centers primarily contain the electronic equipment that we use for processing. So we are talking of servers here. They are part of this system. And also all equipment to do with storage and all equipment to do with communications. That is all the network equipment. They fall under this this IT equipment area of a data center. And this is quite an important area. This is quite an important area because collectively, all the equipment I talked about, it processes, also stores, it also transmits all the digital information. So it is, in short, known as the information technology equipment or IT equipment. And this equipment is further, so IT equipment is further broken down into compute devices like servers. We also have network devices like our switches, our routers, and even our printers. They fall under the network devices there. Then we also have IT support systems like all the PCs or the workstations or whatever remote management systems that we use. They fall under the IT support systems. Then also we have storage devices that we use for backup storage and any media libraries or any virtual media libraries that we use in the data center. They fall under the IT equipment. Moving on to the power system. As we know, data centers they consume a lot of power, and because of that, they usually contain specialized power and backup equipment, so as to maintain a very high quality power and also environmentally controlling environmental control equipment so that we maintain proper temperatures and even the humidity within the data centers. So power is very critical, and some huge data centers can actually consume more power than even some small cities. So under the power systems, we have things like backup generators, even the main power grid, the transformers included, and all the UPS systems. Power system, the reliability of the power system is very critical even for disaster recovery and also for the reliability of the data center, because we want to always make sure that there is limited downtime in our data centers. And to do that, if power is not reliable, and in the event that the main source of power, for example, if we have electricity, if we have lower voltages or there's a fault in the main power lines, then the data center should not be affected. It should always be powered, and all the equipment to support that it falls under the power system. Then the third one is the cooling system. It's the cooling system. And this is a very important one because a data center is usually a contained area, a small area with a lot of devices that generates a lot of heat. Since we said power consumption is very high in data centers, it also means every kilowatt of power that is consumed is later emitted as heat within the data centers. So there should be a way of controlling that heat so that the equipment do not fail due to excessive heat. So all the equipment to do with controlling the physical environment inside the data center to allow efficient and reliable cooling systems to maintain the reliability of the data centers so that they are always up with cooling. I will quickly move on to the history of data centers. The history of data centers, and here I have a timeline of the important aspects when it comes to the history of when it comes to the history of the data centers. It all started in the 1940s to the 1950s with the birth of computing. And at this stage in the 1940s, that's where, the first electronic computers were first made or were first developed. Computers like the ENIAC, computers like the UNIVAC. These computers were very large and actually required dedicated spaces. Like the ENIAC, it was actually up to 30 tons big. So it needed dedicated spaces, actually often housed within big rooms in the laboratories of universities or other government facilities. And in the 1950s, that's where the UNIVAC 1 was, which is actually the first commercial computer, was delivered first to the US Census Bureau, and it marked the beginning of the need for dedicated facilities to house computer systems. Right in the 1950s was basically those computers were big, so they needed dedicated spaces to be housed. Moving on to the 1960s, the period of the emergence of mainframes, where around 1960, mainframe computers were introduced by companies like IBM, which actually led to the need for specialized environments so as to support these machines. Also, that period, IBM launched a system which actually provided a standardized architecture for mainframe, which by doing so also increased the demand for centralized computing facilities. Moving on to the 1970s, the rise of dedicated computer rooms. In the 1970s, organizations began establishing dedicated computer rooms, which were often climate controlled, and the equipment, these data centers were equipped with power and cooling systems so as to protect the sensitive equipment in those dedicated computer rooms. And the term data center began to emerge in the mid-1970s as business also started to formally recognize the need for dedicated facilities to manage their growing data and computing needs. That takes us to the 1980s, the period of miniaturization and local area networks. Why were these important in the history of data centers? Early 1980s, the development of microcomputers and also the development of personal computers, the PCs, began to actually decentralize computing. Though computing was being decentralized, however, large organizations still relied on centralized computer rooms, which we now call data centers. And the establishment of local area networks as well allowed multiple computers to connect within a building, which led actually to more data management. So yeah, in the 1980s, there was microcomputers, but still the need for centralized data management was there. So use of computer rooms or data centers persisted still in that period. Moving on to the 1990s, the internet boom, which is a critical period where the World Wide Web was launched, leading actually to an sort of explosion of data and the need for more robust data management solutions. Around that period, internet service providers as well began to establish large data centers so as to be able to host the websites and manage the internet traffic that was now being very common those days. And also, that's where the issue of co-location became very popular as companies and businesses, they started to rent space in data centers so as to house their servers and also to allow for cost-effective management of IT infrastructure by sharing data centers or renting space from other companies for them to put their computers. Then moving on to the 2000s, where virtualization and outsourcing came into play. And the virtualization technology began to gain traction that period, which actually allowed for multiple virtual servers to run on a single physical server. And this technology actually enhanced this technology, it managed to enhance resource utilization and efficiency during that period. And in that period, that's where in the mid-2000s, that's where the rise of cloud computing actually led to more significant changes in data center design and also data center operation, where companies like Amazon and Google began building large data centers which were scalable so as to support their cloud services. Moving on to the 2010s, the period of hyperscale and green data centers, where this concept of hyperscale is where data centers are now characterized by facilities, massive facilities rather, is built to support the large cloud providers and the big data applications. So in this period also, companies began focusing on energy efficiency and sustainability, which actually led to the rise of the green data centers, and also further on innovations such as advanced cooling systems and renewable energy sources became more equivalent during that period. And during that same period also, that's where the tier standard by the Uptime Institute was published there, which actually defined data center performance levels, which led to improved design and even operational standards for the data centers. Then moving on to the 2020s, that's where the period of edge computing and other advanced technologies. In 2020, because of the COVID-19 pandemic, the adoption of cloud services was actually accelerated, and also the issue of remote work, which increased the demand for flexible data center solutions. Same period, edge computing gained prominence as well, as organizations actually wanted to process data closer to the source, which led to the development of smaller and decentralized data centers. In that period as well, the emergence of artificial intelligence and machine learning technologies also began to be integrated into data center operations to facilitate enhanced monitoring, things like predictive maintenance, and also resource management. And present day, now data centers continue to evolve with the increased focus now on artificial intelligence or AI-driven operations, and also on sustainability, and also on security, and also the demand for data privacy, especially this present day, and the demand for data privacy and compliance with different data protection and data privacy regulations is actually shaping the design and management of data centers in the present day. Next slide, Nyasha. Now, moving on to design considerations, we're going to look at a number of things. Some of the things I've also touched on them as we were talking, as I was presenting in my earlier slides. We're going to talk about power, then we're also going to talk about efficiency, redundancy, environmental controls, security measures, and scalability. Those are some of the things that need to be considered as we are designing our data centers. Next slide, Nyasha. Right, then starting with power. Power is a critical component of any data center, which also ensuring a reliable and sufficient power supply is very essential for uninterrupted operations. And when we are designing our data centers, when it comes to power, we have to take into cognizance a number of things, like the power capacity, where we need to determine the total power requirements of the data center based on whatever the types of servers or the equipment that will be housed in the data centers that we want to design. Knowing the power capacity is also going to inform the kind of power sources as well that we are going to choose, the redundancy in the power as well, so that we have reliability and with a steady supply of power. Then also issues of backup power, and we have two main sources of backup power, which is static power, where power is stored in some form of chemical energy in batteries and other UPS systems that may be used. Then also rotary backup. This is where we have backup power with moving parts like generators with flywheels and what have you to generate power for us. And the goal of power is always to make sure that there's a steady supply of power, and if one source of power is disrupted, or there's a problem with one source of power, at least we have a backup that is able to power the data center until the problem is solved. So, and also need to plan on the how the power is going to be distributed, how efficient our power distribution units, etc. Move to the next slide, Nyasha. Thank you. Now, on efficiency, it's also important to consider the issue of efficiency, and designing an efficient data center is very crucial for reducing the operational costs and also for optimizing resource use and minimizing environmental impact. And the efficiency considerations we have to consider. We have power usage effectiveness. How effective is our power? The cooling efficiency, whatever cooling. Hello, excuse me, guys. I'm in a meeting. Can you? Yes. Sorry for the disturbance. The cooling efficiency is also important, since we've already discussed the issue of cooling systems before. But just to emphasize that cooling systems should actually be designed so as to minimize the consumption while also effectively managing heat as we go. Then we have also on efficiency, we talk of energy efficient equipment. As we choose our equipment, we have to use equipment that is actually energy efficient, servers and storage. Because sometimes even in other companies in the United States, you see companies like Facebook, they also choose areas that have energy efficient equipment, like the source where there is hydroelectricity, which is actually renewable, rather than using states or cities that are making use of maybe coal energy to generate power. So energy efficient equipment must be energy efficient and also make use of renewable energy sources as we design. And today we also now have the increased use of solar panels and solar farms now being erected everywhere, so as to act as a source of renewable energy. Then, of course, as we are designing that, the rack density, where we prefer high density racks, so that we optimize the use of space within the data centers. And if space is utilized by using high density racks and also by using modular designs when designing the computers, it means the data centers can easily scale up, and we make optimum use of the available space, which results in efficiency and also even reduces the overall cost of even cooling, as we have more servers, more equipment fixed in smaller areas or in smaller data centers, which increases efficiency. Then, of course, general design and layout, where also we are talking of space optimization, whatever the zones we were talking about, the data hall, the ancillary space, the support space. How are we going to organize the space so as to be able to optimize and make best use of the available space is important. Next slide, Nyasha. Then also we are talking of redundancy. It's a very key aspect in data center management. And redundancy can be in any form. whether it's in terms of power supply, whether it's in terms of the cooling systems. And for redundancy, basically, we are saying this is an operational requirement of a data center for especially for large companies where we are planning ahead in terms of a disaster recovery, in terms of business continuity, and also in terms of general reliability and uptime of the servers. And it refers to the duplication of certain components or functions of a system so that if they fail or need to be taken down for maintenance, others can take over. So it all depends with what the goals of the company, what are the goals of the company. But there's some necessary redundancy if we want to data centers that are reliable in terms of cabling. For example, a huge company, we always want to have uptime close to 100%. So there's need to have a backbone, maybe internet connection, then also a backup internet connection to the server, such that when one service provider is down, another service provider is up. Even in terms of the servers within the data center, most companies, they have duplication in terms of there's a primary server, but in cases one of the servers, the primary server is down, a secondary server kicks in, and other modules actually are mirroring each other so as to ensure a reliable service. So anything that we are duplicating is for redundancy, and redundancy is necessary to improve on reliability and availability of service. If anything happens, then of course the issue of the whatever the tier standards that we choose to use, so that we at least have we are able to maintain our data center without affecting service delivery. Next slide, Nyasha. Then, of course, there's the issue of environmental. There's the issue of environmental controls, and this is also an important one, which is of course linked to the cooling systems we're talking about. We should be able to control the environment within our data centers and continuously monitor the temperatures, the humidity, and all other smoke levels and what have you, and have systems, cooling systems that maintain optimal operating temperatures within the data centers. And data centers also should be fixed with even fire suppression systems in case a fire breaks out in the data center. There's automatic fire suppression so as to be able to safeguard and save company information. Next slide, Nyasha. Then we have security measures, and of course, security measures in a data center can be physical or cyber security. Under physical security, we are saying data centers must actually have very tight and robust physical security measures, like access control. The physical access to the server, must be strongly controlled. There should be surveillance cameras, for example. There should be even human security guards manning the entrances. Apart from surveillance, there should also even be biometric systems, because data is the most prized possession or asset of any company. So physical controls must be tight so as to restrict entry into the data centers. Apart from that as well, cybersecurity protocols should also be employed, given the increasing threats to data security these days. We should employ security measures like firewalls, like intrusion detections, and also regular audits are also essential so as to make sure that the company information is not hacked or does not fall into the wrong hands, and to be able to implement multi-layered security protocols so as to protect data centers is very key. Next slide, Nyasha. Then, of course, as we are designing our data centers, we should design them with future growth considerations in mind. A data center design must account for the future growth. This involves a lot of planning, of course, so that we know moving forward what probably would be the additional racks that would be needed, what would be the space that would be needed, and whatever designs that we are going to use in that data center should actually be included or factored in as we are designing the data centers, and even the issues of bandwidth that is required so as to sustain the amount of information and the transmission of data to and from the data center should be taken into account, and projections made as to how the information, the demand for the information, the demand for the service for the data center is going to go, and plan in advance so that we are able to scale up or even scale down should the need arise as we are designing our data centers. That was my last slide. Thank you very much.
Thank you very much, Group 1, for that presentation. And we have Doc with us here, Dr. Nofunga.
Yes, how are you, Tim?
Yes, Doc. Before we can make any comments, we invite you to comment on Group 1's presentation, and if you have any comments, additions to their presentation.
Yeah, what I can say, the group did justice. They did a wide research and with enough depth. But what I'm seeing lacking in these presentations is as they flow from one individual to the next, there is no citation of wherever they are getting the content that they are presenting, because this content, from what I could see, it's not coming from themselves. Of course, they've comprehended enough literature and detail to make a comprehensive presentation. But what I'm seeing is lack of citations. Who is saying edge computing is computing closer to the gadget, or that happens on the gadget? Who says frog computing is a step on the edge? When you hop one step from the edge, you are now frogging. And then when you get out of the frog computing, you now get into the cloud. Who is saying that? We need students to be citing authorities who have said that. We said cloud computing is this is this the American society, the NIST society? Is it the one that came up with the general definition for cloud computing? I'm seeing that missing as they present, but otherwise the content is very good, but it lacks the academic rigor in terms of referencing and in-text citations as they do their presentations. Otherwise, it's good work, but those areas are found wanting. Thank you so much.
Thank you very much, Doc. Who am I to say these guys need to improve this when the doc have just applauded them? Thank you very much, Group 1, for the presentation. So your final write-up must include all those authorities, proper citations. We use upper 6th edition in our citations, and also include especially the last part, because we are going to share these presentations. The last part, thank you very much, Ms. Polycarp. You were presenting the typical slide presentations where we have powerful presentations coming from one line. But on your final presentation, please add content so that when you were presenting on cooling, the HVAC system, the heating, ventilation, and air conditioning, part of it must be stated so that others might gain more insights from your presentation. And also the power redundancy, you need probably to mention, for example, when you discussed about power backup using solar generator and our ZESA, you need to probably write that so that in the case someone goes through your presentation, you would need to mention that. And finally, on the security controls, we have the three-factor authentication, where we have something that we have, something that you know, and something that is on you. For example, the biometric that you mentioned, we just need that stated explicitly. Then going to Nyasha and Forchuk, I was requesting real-world examples on the part of the characteristics in the cloud, and said you will present it, you will give us at the end of the presentation. For the sake of others, can you just tell us the real-world, the realia application of those?
Okay, thank you, Sir. I for the multiple tenancy that you asked, where we have a single software application that serves multiple customers, like these are the ones that will be acting like tenants. So though I'm not exactly business inclined, I think the example that I can come up with is the one that we use for the health, like the DHIS2 or the electronic health records, where we have different hospitals that act as tenants, though they're using the same servers and infrastructure, but they don't have like no one hospital has direct access to documents or records of the other hospital. Like they each maintain their own privacy in terms of how they manage their document and their client data.
Thank you very much. She was discussing on multi-tenancy. We have others who are just listening. You are free to ask questions from group one, so that areas you need to be polished, they are here and ready to answer you from their presentations. So you can ask whatever you want to ask. Those who are waiting to present, please, you can ask whatever way you need clarification from their presentation. So are we saying everyone managed to grasp or if managed to acquire knowledge concerning the cloud, the evolution of the cloud, the differences between edge computing and fog computing, as previously said by the doc? I wanted the real world examples where we are saying we have the drone technology, those drones. Currently we have a war in Ukraine, where Russia and Ukraine are attacking each other. What kind of technology is being used by those drones? What can we say? Is that edge computing? Is that fog computing? What kind of technology? That's the kind of reality we are talking about. What can you say, class? Drone technology. Where is Mr. Kudzi? Mr. Kuzai, what can you say, sir? This is what we'll be expecting when you are writing. Master student must give relevant examples. What about Mr. Garland? Are you in here, guys? Yes. Mr.
Hello,
Garland?
sir. How are you?
Yes.
Yeah, what I think in terms of drone technology is where we are seeing the technology being revolutionized, especially on the issues of edge computing. We are seeing that a drone will be flying while it is remotely controlled, and we see that there is a lot of integration that will be taking place. We have the geographical positioning sensor system, the positioning systems in place working. Then we also, so the integration which we see is that we have the GPS, which is a system which is being controlled on another servers and everything to identify locations on the ground. Then we also have the precision of a drone. Let's say it is carrying an armor. It just been gathered and it becomes more precision. Directly where it has been instructed to attack. So we are seeing that in the case of drone, yes, it's robotics, but we are seeing that this robotics has gone far to the extent that it can be sent over kilometers and kilometers. Because initially when they were introduced, they were covering just very few kilometers, but now we see we can see a drone being deployed from Russia, from Moscow, going to Kiev. Rondodon is a bomb rover at the same time, but also on the intrusion detection systems. We see that there is also intrusion detection systems that have also been introduced, especially in cyber, in military warfare, that can detect the drone before it's attacked. So there is an element of edge computing, there is an element of remote computing, which has been integrated together in the development of those systems. And also there is an element of big data, which is being used, because we are saying, as the drone will be flying over kilometers, rarely sensor different types of locations, different data of locations, and it should make analysis and ensure that run rover at the exact position which it has been instructed. Also, even in the issue of use of drone, either in the healthcare systems, we also saw them in China when they were deploying those COVID vaccine sprays. When they were spraying the COVID vaccines, they were also using the technology, meaning to say the technology is not just being used in the military, but it is also being applied on the day-to-day activities. I think that's what I can say, sir.
Thank you very much for that insightful explanation. Basically,
I'm liking the discussion and the input from the contribution that is coming from Nyasha. I think they are using both edge and fog. That's true. On another part, just to make a decision in real time as it will be navigating, but at the same time, it's getting some input from a central controller. So it's now fog. Then it relays that information maybe to some other server that is resident. Maybe if it was in Ukraine, it has got a server in Ukraine, and then it transmits that data back to Russia. So it will be now basing on the cloud-based data. So we've got cloud computing, and then fog computing and edge computing. So these are technologies that are complementing each other to provide a real-time solution.
Thank you very much, Doc. So we're moving on. So we have a lot of examples from this. We have the driverless cars. You can mention that again, where we have computation being done at the edge of the network. We were saying the driverless car is moving. It is capable of navigating all the terrains. So the computations are being done at the edge of the computer, but however, the network, but however, some data is being sent at the fog. That gives is probably the GPS system is being linked there. At the end of the day, all the data is transferred to the cloud. So as explained by the doc, you need to have real-world examples for these ones. When discussing the differences, you need to give real-world examples. Any other contributions, ladies and gentlemen, before we move to the next presenters? But the issue of time now, time is no longer on our side. Will they finish presenting today? Any other contributions? For you, what were you supposed to give us? You were supposed to give us something for you. I remember when you presented, you were supposed to give us the reward examples. Yes, can I have the part that was presented by Fortunate? Nyasha? Nyasha, you're
Hello,
still the presenter. Can you just scroll down and the part that was presented by Forchu? I wanted some reward examples from a presentation. She just gave us the theoretical concepts. Can you
okay,
just
let me just go back to that part. So, but she was comparing cloud computing versus fog computing.
oh wait, this is that we've just done. So
Yes.
yeah, I think you've done justice, you guys. Thank you very much once again for your presentation. Maoneke given. Are you in?
You are now unmuted.
Yes. Any contributions, any comments, any questions? Everything has been said and you say it's enough. Well,
You are
thank
now
you very
muted.
much. Thank you very much. So, who are our group 2 members? But before that, let me give you something that I have. I'm now taking the presentation rights. Sorry, I'm looking for. Well, I just wanted this party. No, it's not the document. This is for group 2. Sorry, let me look for another one. Yes. I wanted wanted this party. So, for instance, when you are writing, this is the cases that I wanted you to know about. Are you able to view my slide, everyone? Hi, Tim?
Yes.
You are able to view the maze. So I wanted you to give me, let me move to the hierarchy. Probably this is somewhere here where we were saying the comparisons, the type of examples, the reward examples that I was looking at. So if you see fog computing versus edge computing, those examples where we were saying of talking of driverless cars, those are the autonomous vehicles, versus on fog computing, these smart cities. Fog computing optimizes localized decisions, decision making in environments. Examples include traffic management, environmental monitoring that we have for fog computing, and those ones are for edge computing. So as an addition to what Group 1 members have just given us from Nyasha, they were saying in the health sector, we also have things like the insulin pump with inbuilt sensors that monitor blood glucose levels, adjusting the user's demands probably. I don't know if I am reading it well, but I think that's what she wanted to say. This can also be linked to devices like one smartphone or a continuous glucose monitor. And I think it relates to fog computing, where a smart home devices, where smart home devices like smart lights and security cameras can also be using edge computing technology. That's another example from Nyasha from the health sector. She's from the health sector, and she's telling us examples that are related to an area. So if we are good to go, guys, Doc, can we allow Group 2 to present? Considering the time right now, we are supposed to finish at 6 o'clock.
Yeah, let Group 2 present.
So Group 2, we are calling upon Group 2 members. Who is guys? Group 2, we have
Good afternoon. Good afternoon, sir. It's Matarise speaking.
Matarise, yes.
Yes, you may give me the rights.
Oh, so you know the presenter, Matarise, can upload your presentation. Make it downloadable, please, so that others can download your presentation.
All right, sir. Sorry, sir. May I have the rights again?
I've just issued you presentation rights. Can you go to the plus sign that is at your lower left corner?
All right, sir.
Then click it, manage presentations.
Yes, I've done that.
Browse files.
Yes, I locate the file. Let me just.
Before uploading it, there is an arrow that shows that you can download it from here. Just click it because it's slashed sort of to stop us from downloading. Just click it so that it will be downloaded. Then you upload. Just confirm.
Just a moment, I'm locating the file.
Well,
No, I'm trying to locate the file, but. Sorry, let me just see the file in the folder which I'm trying to locate.
or you can just share your screen so that we can help you. We can assist you find it, your file.
No, it's in the, what is it? It's in the file I'm trying to locate. But when I'm sharing now, I cannot. If I go to that file, I'm not seeing it. Even I tried even to save it again in the same folder, saying already exists, but
If you fail, can you send it to my email so that I can upload it for you?
all right, say
Yes, you can send it to me
that.
via WhatsApp, or you can send it via my email pnauro@cut.ac.zw. Can you just be quick?
Pinauro 8.
cutcut.ac.zw.
.ac.zw.
Yes.
Right, I've sent.
pnauro@cut.ac.zw. I haven't received anything as yet. Now nothing. Refreshing again. Yes.
Yes.
Yeah, thank you very much. Let me download your presentation. Oh, what kind of a document format is this one?
It's a PowerPoint.
But we saved it as. Which extension is this? WPP. Then
Correct.
PPTM, is it uploadable now on Big Blue? You have to change this file format first. I think that's the reason why you were not able to view it.
Uh-huh. Let me check.
You can make it a PDF, if possible, from that end.
Or let me try to. PDF. Okay, I think. All right, so let me try to upload from this end.
Let me give you presentation rights. Mutaris,
Yes.
you are now the presenter.
Okay, thank you, sir. Like you were saying before I upload, I have to tick somewhere.
Yes, I was saying just untick that slash the download arrow.
Let me open it first. All right.
Browse, then yes, before uploading it. You manage?
Yeah, I managed this uploading.
Okay, thank you.
Welcome, sir. Right, from my end, I can see it is uploaded. I don't know if you can see that side.
Yes, you can see it.
Okay, thank you.
Go
Sir.
ahead.
Okay, good afternoon, class. We are group 2, and we're going to present on the following. Sorry, let me just open it also from my end. Right, we're going to present on the following points. I understand we have this question. So let me quickly dive into our presentation. Right, I'm going to start by defining what is cloud computing. Right, according to STEC 2010, cloud computing is providing developers and IT departments with the ability to focus on what matters most and avoid unvariegated work like procurement, maintenance, capacity, and planning. But in other ways, we're saying what is it? It is the storing, managing, processing of data online instead of your own physical computer or local server. An example of cloud computing is iCloud. I believe some of us who are using an iPhone, we are familiar with this one. And so there are different cloud computing models, which are software as a service, platform as a service, and infrastructure as a service. I'm going to start by explaining software as a service. Software as a service, it is a method of software distribution in which the SaaS provider hosts applications on a server and makes them available to customers over the internet. So here we're saying, what is it? Instead of you having the software in your computer, it can be hosted on their servers, and then you can access it. An example is, Gmail. Gmail, we cannot install it on our computers, but we can access it through the web browser. So instead of installing, maintaining the software on your hard drive, you simply access it via the internet browser, and you not worry about software management. For you, it's just to use the software. Things like software updates, debugging of errors, it is done for you by the service provider. Right, so these are the examples of software as a service. The other examples, we've got Microsoft 365, we've got Zoom, Adobe Creative Cloud, Salesforce, Google Workspace apps, and we've got Slack. Right, let's look at the characteristics of software as a service. The first one I'm going to talk about is it's cloud-based. These softwares are delivered or they reside on the cloud. They are only accessible via the cloud. Users can access these applications through a web browser by installing them on their devices. For example, I gave an example of what is it, a Microsoft 365. Users can access applications such as Word, Excel, PowerPoint through their browsers. Right, another characteristics is a subscription model. This is at this point, users pay a recurring fee for access to the services, which means if you want to access your Microsoft 365, there's a certain fee which you have to be paying, and this amount can be paid either monthly or yearly, depending on what you're comfortable with. The other characteristics is continuous updates. Right, things like bug fixes and security patches are continuously sent to you so that your software will continuously run smoothly without any problems, while we are focusing on just doing what is your main business. Right, another characteristics is accessibility. Software as a service, such platforms allow users to access these softwares from any device and from anywhere in the world. So it's another characteristic of software as a service. Right, we also have another characteristic, which is scalability. It allows users to choose the plans based on their needs. Right, we said, what is it, on Microsoft Word, users pay a recurring, fee, and these fees are different. They are different packages. We are talking about the costs. So each cost comes with certain offers of services, as well as for example, if we are talking of storage, if you are paying they might charge you something like maybe $100 for 2 gig. If you want 4 gig, they charge you 200. So that's an example of scalability. If you want more services, you have to pay more to be able to receive those services. Right. Another characteristic is collaboration and integration. These services they support real-time collaboration, which allows multiple users to work on the same task simultaneously, which means you are able to create a document. For example, if you're using Microsoft Word, you are able to access the same document and work on it simultaneously. Despite of the location, you can be in different locations and you are able to work on the same document. So these are the characteristics of software as a service. Right? I will quickly dive to platform as a service. This is a cloud computing model that provides a platform and environment to allow developers to build and deploy applications, services over the internet. Developers can build, compile, and run their applications without worrying about infrastructure. Right? For you to be able to develop your software under normal circumstances, maybe you need a computer which is high processing speed. You need the softwares. So through the use of these models, like a platform as a service, you just need to pay for the service, and then you are given the platform whereby you are able to develop, build, and deploy your applications without worrying about the maintenance of the infrastructure or the cost of the softwares. So examples of platform as a service of what Amazon Web Services, of what Google App Engine, of what Google Cloud, and IBM. Right, characteristics of platform as a service. Number one, we've got development environment. Right, the PaaS offers a complete environment with tools, libraries, and framework to develop, test, and deploy and manage applications, which allows the developers to focus on programming and deploying their applications. And then another characteristic is the support towards multiple programming languages. As we know about various programming languages, so depending on the one you want to use to develop your application, these platforms, they support multiple programming languages or of infrastructure.
Sorry for interjecting, Mr. Matarise. You are presenting very well. Do you understanding? Yes. So I'm requesting you guys that exactly 6 o'clock, 2 hours per day. So can you probably, you guys, will finish your presentation tomorrow? Sorry for interjecting while you are presenting. Tomorrow you finish. I'm sure tomorrow we have a lecture, same time. So we'll be having group 2. We will now on the characteristics of platform as a service.
Yes, sir.
Yes, so you finish your presentation tomorrow. You've garnered some marks as of now. Wangawa is 6. Wangawa is 6. So sorry for that. So guys, tomorrow let's be on time exactly at 4. Let's meet at 4. Omana the make use akawanda omana hapana kusema excuses. Make it a point that we on time. Tomorrow at exactly 4 o'clock we meet. Then group 2, you finish your presentation. We have discussions, questions from the floor, and comments from the floor. Then we proceed to the next group. Be organized because we have some assignments that I will give you soon after your presentations, and also there's going to be an individual assignment as well as a test. So make it a point that we finish this on time. We make the discussions, then we have our practicals before the doc will tell us whether we are going to meet to go to one of the cloud service providers, so that we can have a hands-on appreciation of how the cloud environment looks like. Dr. Shinofunga, you can give us how we are the trajectory, the path that we are going to take.
No, it's for tomorrow. I think let's release them. Some had planned to travel around 6. Let them travel. We'll resume tomorrow. Thank you so much, guys.